Good morning, and welcome to the third episode of our WVD series. I'm hoping that by now you're beginning to gain a firm understanding of the technology and be comfortable in pricing the solution. Today we want to focus on optimizing your user experience and look at the technologies that can be employed to help you do so. This will include profile roaming and the regularly requested Microsoft Teams optimization feature. As always, I'll be joined by our resident WVD specialist, George Wood, and he will help us both understand and then implement the features. But before we welcome George, let's take a moment to think about why these optimizations were important. Now, when I started my first job in IT, my desktop was a sad little terminal with a basic green screen. As you can imagine, customization wasn't top of mind, but this all changed when we later switched to Windows 3.1. Suddenly, I could customize my background, my fonts, and my experience. The trouble was, the computer was shared with another person, and to be honest, she was hell-bent on using the headache-inducing Critter's background and the Valentine's color scheme. It was a case of one profile per computer, and after futile pleads for normality, she ultimately won the customization battle. Fortunately, Microsoft addressed this with the introduction of user profiles in NT4. A true multi-user desktop experience. User profiles were perfect. Each user had a separate login and environment variables that persisted from session to session. This laid the framework for many future iterations of the operating system and ultimately the evolution of roaming. Now, roaming profiles store the user's customizations on a network server rather than the local machine. Typically associated with a user account via an identity solution, the profile is pulled down from the server regardless of the network-connected machine you've authenticated against. Now, this worked well, at least back then, but as applications grew bigger and customizations more prevalent, our roaming profiles rapidly increased in size, which meant that logon times began to suffer. Once again, administrators had to reevaluate how profile roaming could be achieved. If we jump forward to today, and more specifically the deployment and running of a common VDI solution such as WVD, administrators are tasked with providing environments that both feel and perform as though our end users are sitting in front of a physical desktop. So George, can you run through how this can be achieved?
Thanks, Dan. It's great to be back. So as you mentioned, remote desktops are a critical part of an IT strategy for many businesses. And because of the non-persistent nature of these solutions, it's important to have a simple set of tools that manage both the applications and the user profiles. Today, more and more companies are turning towards technology such as FSLogix to help them improve the administrative experience and in turn simplify the management of remote environments in both public and private clouds. The benefits include reduced sign-in times, file optimization, and a native local profile experience. As you mentioned before, with a roaming profile, the user experience has to be copied down from a network server at logon. FSLogix removes these requirements by mapping a VHD to each user profile and simply mounting it at logon to eliminate those delays. So to achieve this, there are some prerequisites that need to be configured. So let's jump into a demo and take a look. So the first thing we'll need to do is create a storage account. There are a number of solutions that we could choose. However, because this is a simple proof of concept, I want to minimize costs and opt for an Azure file share. I'll keep all the defaults and step through creation. Once deployed, we need to run a PowerShell script to join our file share to the domain. I'll set the execution policy to unrestricted, import the required PowerShell modules, and authenticate to Azure before running the join AZ storage commandlet.
Now, I appreciate that we are going through this at speed, but rest assured the script has all of the prompts you'll need to complete this process.
Yes, and we have a whole bunch of useful documentation to accompany that script as well. Now, once done, we can jump onto the domain controller. Notice that as I check AD users and computers, a storage account is present. This is also reflected in the Azure portal, as you can see on screen.
Okay, so let's just take stock of where we are. We've created a file share, registered it to the domain, and checked that it can be seen. What are we going to do to ensure that the content is protected?
Well, there are two ways that we can approach this. We can assign share level permissions through role-based access control or be more granular with NTFS. For the sake of our demo, let's stick with role-based access control through identity and access management, but in a production environment, you would want to use both of these. Now, I would also recommend checking out the following link to help you configure Azure files with Active Directory. So, from Identity and Access Management, I will select my first role, the SMB Share Contributor, and assign it to our WVD users. I'll also add the SMB Elevated Contributor role to our Daniel Baker account. Think of this as an administrative role with full access permissions, which we will need in order to complete the setup of our service. Next, I will copy the file path and mount it into a new network drive on our WVD VM, ensuring that it is set to reconnect at sign-in. From here, we can begin the installation of FSLogix.
Now, am I right in thinking that the license is included with your WVD entitlement? Are there any other costs associated with setting this up?
Yes, you'll need to consider the additional storage required for your profile containers, but we do have scripts available that can help reduce their size.
And what happens with the existing profiles? Do these get overwritten or simply copied across to the new location?
So that's a great question and something that we need to be cautious about. Notice that I've added a new registry key that sets our profile VHD location. Now, when the system determines that a user should have an FSLogix profile, the local one will be deleted.
Okay, so this is something that should be set early in your WVD deployment as to avoid losing any settings and customizations. So can you explain what a flip-flop profile directory is?
Well, while I can't comment on the naming convention, what I can say is that it builds a folder structure to set the username and the security identifier, which obviously makes maintenance and troubleshooting that much easier. So with that, I will configure our final registry key and change my disk from the default VHD to the new standard VHDX.
Okay, so back into our whiteboard, we've configured our identity and access management and added two new roles, a standard user role and an elevated administrative role that is needed to complete the installation of FSLogix. As you mentioned, although the licensing is included with your WVD entitlement, you will need to be conscious of the fact that storage will come at an additional expense. And to set expectations, some of these disks could grow fairly large, especially with application customizations.
They can, so I definitely look at the link on screen, which has been created by one of our Microsoft Global Windows Virtual Desktop Black Belts.
Now, you made some changes to the registry, and as discussed, one of the settings will remove any local profiles when FSLogix is detected. Again, I would err on the side of caution with this and ensure that you have all of the settings you'll need in place before you proceed. Okay, George, what's next?
So now that we've applied all the settings and rebooted the virtual machine, we just want to ensure that the VHDX has been created and our profile has successfully been stored. To do so, I'll open Disk Manager on the virtual machine. Notice that we have a third disk of around 30 gigabytes. This is a dynamically sized disk that hosts our profile information. We can also check from the storage account too. If I head back into the Azure portal and then into the file share, notice that we now have a folder for Daniel containing a VHDX of around 292 megabytes.
Thanks, George. That was a brilliant demo. But let's change focus. Now, we know that many companies are migrating towards a VDI solution such as WVD. And I guess one of the most common questions asked is, how do I optimize performance for applications such as Microsoft Teams? Now, as I understand it, Teams works fine in this type of deployment. In fact, I know it does as I regularly use it myself for meetings and collaboration from an old Surface Pro 3. And while the service runs fine through WVD, you can also increase performance by offloading the processing of video to the local client. Can you perhaps run through how this is achieved?
Sure, let's jump into a demo. Now, here I am using Teams in a WVD session with no optimization. Notice how everything is working as it should, including things such as audio and video redirection. Because we've got no optimization, my CPU is fluctuating and in fact peaked around 71%. This isn't a problem for single seat instances, but for scale deployments, this could quickly become an issue. Now, let me modify the registry on the Windows Virtual Desktop host to specify a multi-session environment. I will also download the Web Redirector service and once again install Teams through a PowerShell command to update the configuration. As I connect back into the service, we can see a banner stating that we are now WVD optimized, and if I open the Task Manager once again, you'll notice that the CPU consumption is drastically reduced.
Thanks, George. That was a great insight into optimizing WVD. As always, it's our hope that you've enjoyed this session and welcome any feedback or suggestions you may have. Until then, stay safe and thank you.